G'day everyone. So we're in the pursuit of finding an issue with the audio on the trike, and today we're going to have a look at the circuit diagrams and the wiring layout on the aircraft and just basically identify where we want to search for that. If you saw in part one of this series, I showed you a new instrument that I'm going to use to diagnose the audio, and it's called a digital storage oscilloscope. And in this episode I'm going to find out where we need to look. This weekend coming up is actually a long weekend here in Australia, and we're going to have a little bit of time to be able to really dig in deep into the aircraft's wiring looms and see if we can work out where is this noise coming from. So let's take a look at these diagrams now and have a good look and decide what we're going to do with them. Alright, so in the first diagram, it's a schematic diagram, and there's two regulators shown. There's one that is for the, it's just a generic rectifier by the looks regulator. That's not the one we want. There's another one labelled for the Rotax 912, and that's where we want to be looking. So there's three areas that I've looked at on the diagram. There's another part to this as well, and it demonstrates how the start circuit works. And I'll put that up on the screen shortly as well. So the start circuit basically takes power from the battery through a fuse, through a relay or contacts. There's a button that initiates this. Once you've pushed the button, it turns on the relay and the power flows to turn the starter motor. Once the starter's going, the generator starts on the engine. Once the engine starts, it powers the rectifier regulator, and then it sends power off to the electrical bus, the positive common bus in the aircraft, which supplies everything, for example, fuel gauges, instruments, I guess radios, avionics and everything else like that, and probably lights and strobes and whatever else you can think of. So I would suggest that somewhere between the battery and the bus common, positive, I'm going to see noise, probably on the whole lot. The problem is, why is the noise getting in there and where is it coming from? Is it being electrically induced by electromagnetic interference between cables? And if you look at the diagram coming up shortly, I'll show you what that means or how that can happen. Or is it actually directly connected or not filtered properly on the positive 12 volt bus line in the aircraft, such as is the filter that's on the battery, the capacitor, there's a big, huge, whopping great, I think it's a 22,000 microfarad capacitor on the battery, which is supposed to filter out a lot of these issues. Is it because of that? Don't know. We'll find out hopefully soon. So that's how the machine starts. There's 3 points I've labelled on this first schematic diagram. One is the positive terminal on the battery. Another one is the positive terminal on the capacitor, which actually is probably going to be the same thing as the positive terminal on the battery, as it looks on the circuit diagram. And the other place is going to be on the positive bus, common bus rail for supplying all the instruments. Now, theoretically, and as shown in the circuit diagram, all of those three locations are connected together anyway, so they all should show the same amount of signal level, interference, whatever we're going to find, noise. Now on the second diagram, it represents a picture from the back of the dashboard console with all the wiring and the bus connections, and there's a couple of places I've labelled here, as you can see. They represent what we just showed you on the schematic diagram. And there's also one other concern relating to that induced electromagnetic interference. They have a heat shrunken loom of cables, if you like, coming from the rectifier regulator They're all bunched together and then it goes to the battery via a fuse. Now, is there something else running parallel with those, which should be a filtered line, but it's picking up the generator, which is the engine's AC power output, which then gets rectified, regulated and sent to the battery as DC. So it starts as AC, goes down this loom, goes to the battery, to the regulator, filtered and turned into DC. If there's other wires running with that AC generator line, I'm wondering if there's interference getting in through there, as well as are the strobe lights also running in that same loom and also in common with the power supply going to the intercom and the radio, which are then going to be picking up these electrical noise interference issues. That's an overview of what we're going to try and attempt to do. So this is the hypothesizing side of things, trying to establish what should we try to look for and where. And on the weekend coming, as I said, we're going to have a really good look at this. We're going to tear into it with the oscilloscope. We're going to use these diagrams as some clues as to where to start looking, and hopefully we can actually find the source of the problem. Now we know that we can hear the strobe lights. There's no doubt there's strobe light noises. There's engine alternator generator noises. I guess you'd call it a generator. Power generator for the charging of the battery and running electrical systems. They're definitely the noises we're hearing on the intercom. Why are they going through the system into the avionics? That's what we need to find out. Alright, so I hope that's helped you get a bit of an understanding of what we're going to attempt to do, and it also makes us familiar with the electrical systems on the aircraft so we can better understand if there's a fault in the aircraft, how we can diagnose it and remedy it. There's nothing worse than not understanding your electrical systems. What if you're flying around somewhere, you're out and about, and all of a sudden something's going wrong? And I can tell you, if you know anything about your electrical system in the aircraft, while the system is playing up, while there's a fault there, and sometimes they can be random, and they're the worst kind, or intermittent is the electrical wording. If it's there while you're flying, you can start moving and wriggling and changing things, as I did in this video recently. If you just want to watch, we'll put it here now.
See that? Yeah, push that wire. Let it go, push it, let it go, push it, let it go.
So as you can see, I was wriggling the wires to identify, is this where the source of my problem is? And that's what you can sometimes do. You can tap things and move things and just try flicking switches and seeing if that fault that you've had comes and goes, and that helps you then when you get back on the ground to identify and have somewhere to look when you're fault chasing. Anyway, stick with it. Let's see how we go. I'm interested to find out if we can fix this problem, and if I can, I know there's a few others of you out there with a similar problem. Some of you have said it's possibly to do with the intercom doesn't have good enough electrical noise filtering on the DC input. I've already put a filter on the input and it's still not quite enough to eliminate these noises. There's probably something else going on. Even if there isn't, I'd just like to show that there isn't any major issues there. Anyway, thanks for watching. See you in the next episode. This was part 2. In part 3, we'll be looking at the aircraft in detail. So keep an eye out for that one, and we'll talk soon. Thanks for watching, and bye for now.
Bearer traffic, Trike 6340, enters, lines up, rolls runway 12, Bearer traffic.